The moon's an arrant thief, and her pale fire she snatches from the sun.
The Interplanetary Podcast, the exploration of space for the benefit of all humankind. Your hosts here in North Devon, Matthew and George Russell.
Oh yeah,
Baby Shakespeare.
The past tense for William Shakespeare is "will I was Shakespeare."
Right, is that actually correct?
Would I was Shakespeare.
Would I was Shakespeare. That's good to know. I'm not especially good for those studying A-level English.
Not this is more basic English,
More basic English, okay.
Understanding past tense.
So obviously the podcast isn't going to be about William Shakespeare. We've decided to do a moon special.
A lunar episode or a moonly episode.
A moonly episode or a Selenian episode.
Yeah, Selenian, or you can also call it Cynthian.
A Cynthian episode. Yeah, beautiful. Yeah.
There's so many adjectives that can be used.
Well,
describe something that pretends to the moon.
Well, that's because the moon is undoubtedly definitely one of the biggest cultural influences.
Yeah, no matter where you are on Earth, you can always look up and see it.
Yeah, and not only that, of course, it governs so many things like farming, hunting, cycles of certain animals, the way that they behave, etc., etc. So yeah, big time. It's and of course the months are based on the lunar cycle.
Well, yeah, at least in the Islamic world and other parts of the world, especially in like Asia and eastern places, they use the moon as the the lunar calendar.
Yeah, indeed. Go on then, George. Tell me a few facts about the moon, if you dare.
The moon.
Yeah. Just some your normal facts, like how big is it?
Not fun facts.
Not fun facts, just normal facts. So, like, how far away is it from the Earth?
Well, it varies. So, on its highest point, it's 362,000 kilometers, or 363,000 kilometers from the Earth's center.
Right. That's about 250,000 miles.
Yeah, that's its lowest point. And its highest point is 405,000 kilometers.
So that's because it's in an elliptical orbit.
Yeah. So, was it previously believed that it wasn't
in a circular orbit?
Yeah. Who was the before Galileo, the person who believed that the planets and various other objects in the sky moved in accordance to Platonic solids?
I would imagine Plato.
No, it was
Copernicus.
Copernicus, yeah. Didn't he believe that all the orbits were circular?
He did. Well, yeah, but they were related to things. But it was, yeah. But even Archimedes knew that the moon wasn't sped up and slowed down.
Yeah.
And when he made the apothecary, whatever it's called, device, that actually had this weird kind of loose screw that allowed it to simulate the
I always think it's
moon's
funny.
Orbit.
I always think it's funny when people say, if the moon were 5 meters closer to the Earth, then everything would, it'd all go wrong. But it literally varies by
thousands of kilometers.
Yeah, by tens of thousands of kilometers.
Yeah. Obviously, it's a lot of those things are completely ridiculous. And okay, so it's very far away in terms of its diameter. Roughly, how compared to Earth, what kind of diameter does it have?
Yeah, it has a diameter of 1/4 Earth's, but its density is less than Earth, so that means it has a sixth the gravity. So that's about 0.165 g.
Yeah, well, but although it only has 1/6 of the gravity, it's actually very dense for a moon. For a moon, yeah. So it's actually got a lot of gravity. In fact, the only moon that's actually got more gravity at its surface?
Titan.
No, Titan's nowhere near the gravity. Io, yeah. Io is the one that's got...
Does look dense. It
does look dense, doesn't it? Looks like your mates at school.
Wow.
Yeah, no, is that not very nice?
It's a
Is
deprived
that
area, Dad.
Oh, sorry. Is that politically incorrect?
Yeah.
Okay, sorry. So yes, it's considered a planetary mass object, a PMO.
Okay. Yeah.
Which is defined how planetary mass object. What makes something a planetary mass object?
Is it by any chance something which has a mass comparable to that of a planet?
No, it's not. It's not. It's something that can make itself spherical under its own mass.
So Phobos isn't one of these things.
No, Phobos really isn't. No, it hasn't.
Deimos also not.
No, so Mars's moons are pathetically small.
Potatoes.
They're little potatoes compared to the moon, and so much so that eventually they will hit the Roche limit and just be torn apart. And that actually won't be that long in terms of astronomical time.
How long?
No, I can't remember. It's hundreds of thousands of years, if not millions of years, but soon.
So only like the length of human history.
Yeah, something like that. So, and they will be turned into a ring system, a pathetic ring system.
Like a very thin sort of.
Yeah, but in actual fact, I've talked about this before on the podcast. The moon could eventually become a ring system around Earth
if it got low enough.
Yeah, so it's drifting away from Earth, but eventually it'll start falling back down towards Earth. Because it's
because once if it's close enough, tidal forces can just completely rip it apart.
So that's known as the Roche limit. So as it goes past a certain point, and then tidal forces will just rip the moon apart as it gets closer. But that will be after the sun goes red giant. So whether we actually get to see it or not.
Yeah, if humans are alive, then we will likely be in another star system.
Yeah. So yes, the moon, although it has reached what's known as a hydrostatic equilibrium, right? So that is the planetary mass object definition. It's massive enough to reach hydrostatic equilibrium. In other words, to get rounded under its own.
How round does it have to be? Like rounder than a golf ball or something?
No, it's just enough that it's overcoming all the forces. Like obviously, it's easier for a liquidy planet.
Yeah.
To get into it.
So it takes into account. It's not just about the mass.
Well, there's a disagreement amongst all the different institutions about what constitutes hydrostatic equilibrium. According to IAU, the mass has to be big enough to overcome rigid body forces. In other words, if you're completely rocky like the Earth, it has to still be able to spherize and overcome the forces within rocks to still crush down into a sphere, whereas the moon only managed to achieve it when it was sort of more molten. But its static equilibrium has gone now. It's hydrostatic.
So it's an unfair test, basically. It biases planets made of liquidy stuff.
Yeah, but obviously the moon at some point was liquidy enough to become rounded off. And you can tell that it's it's one of the only conformations of a planet that has been hydrostatically in equilibrium, only to lose it. So it's no longer in hydrostatic equilibrium. It can't overcome its own rocky.
So basically, a planet that's round but shouldn't be given the temperature that it's at currently.
Yes,
implying that at some point it was a different consistency.
Exactly, and there's a lot to learn from that as well, because the bulge that the moon has, caused by tidal forces. So obviously the moon rotates it rotates the same amount of times as it's going around the Earth. So the same face is always
it's tidally locked.
It's tidally locked, and that happens obviously because it's nicking energy off the Earth and it's being slowed down in its orbit because of orbital mechanics. And that's why it's drifting away as well.
Am I right in saying that it's a misconception to say that the reason it's facing Earth is because its heavier side is on the Earth side? Yes,
absolutely. So, but what will happen is yes,
absolutely, isn't it? It's a misconception.
It's a misconception that its heavier side is facing. It'll just slowly slow down, but it will be a heavier side because, of course, as that face faces you, the Earth's gravity is literally pulling that sphere towards itself. So that causes the tidal bulge, which we see the tidal bulge on Earth as
Tides.
waves, as tides. Yeah. so that the sea is pulled up towards the moon, and therefore it's higher up in the sea on both sides of the ocean as well. So you get tides. But it's a permanent rocky tide on the moon where it's been pulled up, but it's been pulled up further than it should have been. So the bulge in the moon, its shape isn't round. It's not round. It's bulging in the middle. And the reason why it's bulging more than it should do is because the moon must have been a lot closer at some point. So there's one piece of evidence that the moon was a lot closer.
And you can work this out using Newtonian mechanics. In fact, Charles Darwin's son, George Darwin, actually was one of the first to work this out, or presumably the first.
Ooh, that's interesting. And so what was his conclusion? He came from the fact that
so he believed that the Earth and the moon were one body, and that due to centrifugal forces, the Earth-Moon kind of system span at such a rate that a chunk of it got launched outwards, that then became the moon.
So you've got like the Earth is spinning so fast, and it can't hold on to the outside edge because it's spinning so fast, and so that outside edge comes off and becomes the moon. That's kind of what he's saying.
Yeah.
I think isn't that called fission? That's the fission hypothesis, isn't it?
I think it's not really a modern hypothesis,
no,
but it is a.
Do you know why?
It was the consensus among scientists in that era.
Yeah, and one of the reasons why it's been debunked, the angular momentum of the Earth-Moon system is very, very high, and that wouldn't account for it.
Yeah, but it's at least closer to the truth than people had ever been.
Yeah, oh no, it was a really good theory.
At least in terms of if you're just taking what the current hypothesis is to be true, it's closer to the truth.
So other formation hypotheses are things like that they accreted together in the accretion disk, so that they actually formed as part of the same accretion disk. But
the most common is the giant impact hypothesis.
Yeah, the giant impact hypothesis. So yeah, go on, explain what the giant impact hypothesis is.
Yeah, so sometimes called the big splash or the Theia impact.
Yeah.
It's this idea that this hypothetical planet called Theia, which is about the size of Mars, collided into Earth about 4.5 billion years ago.
Mm-hmm.
So like very early on in the Earth's development. So like, because the Earth is only something like 4.6 billion years old, so it's very early days. The Earth is still like a molten-ish rock.
Well, yeah, it's very early on in the formation of the solar system. So the Earth is, it might be unrecognizable as the Earth, mightn't it?
Yeah, it's called proto-Earth because it's still yet to gain most of its mass, or like a big chunk of its mass. Yeah, exactly.
So there's a Mars-sized planet that's kind of accidentally drifted in.
Yeah.
Or drifted out, I don't know which way round, or maybe just hurtled into the solar system.
Yeah, it could be at the same height as Earth's orbit, but the idea is the reasons this hypothesis is proposed is because the Earth's spin and the Moon's orbit both have similar orientations. That's one of the reasons. Another is that the high. Yeah, you were saying that the high angular momentum. This is a thing that's quite unusual. And this hypothesis does at least somewhat explain that as well.
It's a lot bigger than the other inner rocky planets, isn't it? The overall angular momentum, and of course, one of the ways of explaining that is that you've had a giant impact that sped the whole system up. So you've got this, you've got this amount of energy that's come in, and that has supplied this excess momentum. The way that the moon is sort of made shows that it was molten at one point, so that the moon had been this like giant molten blob at some point. But it could have only have been caused by a very, very energetic process, like a massive collision. And do you know the first person that talked about massive collisions of planets, by the way, is Lord Kelvin.
Inventor of the Kelvin system.
Yeah, and lots of other things. We've talked about Lord Kelvin a lot on this podcast, but he was, one of the very first people that even suggested the idea of planetary collisions and what that might be like. He didn't come up with this. In fact, it's amazing the great impact hypothesis is a really modern hypothesis as well. There was a conference, get this for the name of the conference, the Origin of the Moon conference.
What are they discussing there?
The origin of the moon, much like what we're discussing now, and that was held in Hawaii in a place called Kona on October the 13th, October 16, 1984. So this is pretty recent, 1984. And this was the first time that the mega impact hypothesis had sort of come up as a very strong contender, and everyone was starting to take it really seriously. And it wasn't because of any kind of new information that was coming in. It was just purely because of the fact that people had taken the hypothesis serious for a while and had started looking at it and going, oh, wow, this actually kind of really like fits the data. You know, this looks really, really interesting. But here's an interesting thought about that impact. That impact would have been so energetic that Earth, the post-impact Earth, would have behaved like a brown dwarf for about 100 years. So the amount of energy would have been glowing.
It's just so hot that it was essentially a star for a bit.
Yeah, it would have had an atmosphere of silicate vapor. It was so hot.
Yeah.
And so it would have had this sort of extended photosphere that was about 2000 Kelvin. And if you'd have been an astronomer in a nearby star system, you would have seen that as a brown dwarf. You would have just thought, oh my God, what's going on there? And so that really hints at a way of maybe providing tests for the theory that you could kind of look out for these kind of short-lived brown dwarfs.
Which would imply the existence of a similar thing happening.
Yeah, exactly.
One of my favorite parts about this this model is that it contains what's known as a synestia, which is just a general term for basically a donut planet, essentially.
Mm-hmm.
So it's it's where you have a really rapidly spinning system of rocks, such that the centrifugal force is more than the gravity of that system.
Mm-hmm.
So the idea would be directly after the impact, you would have had for thousands of years this like just spinning donut that would be
molten donut.
A molten donut that would be a mixture of Earth and the Moon.
Have you ever been to a fair and accidentally had like a molten donut? One of those ones where the jam inside is so hot it permanently disfigures your mouth.
Why are the donuts being heated like that?
Oh, because when you're at the fair, you know, like when you go buy them from the bakery, they're cold. But like, so you can get like in like places they will make the donut there in front of you in boiling fat, and then the strawberry jam's inside getting moltenly hot.
Yeah, so imagine one of those. That is what the Earth and the Moon
may have looked like.
May have looked like in the giant.
That's a sort of extra part of the hypothesis, isn't it? To sort of get rid of some of the things that are a little bit troublesome with the giant impact hypothesis, isn't it?
The problem with this synestia is like with the brown dwarfs, like short-lived brown dwarfs, we haven't seen these things occur in other solar systems, which would suggest either they're rare, hard to spot, or they don't exist.
Yeah, and of course one of the big downsides to this theory, one of the things that they're trying that's kind of like it's not a slam dunk, this theory, and one of the big ones is Theia, as it comes in, smashes into the Earth, and a lot of the Earth's mantle should have come off and sort of form the Moon. That's all very good, but there should have been a large chunk of Theia that also came off and would have been in the Moon, and therefore the composition of the Moon and the composition of Earth should be less similar. But when the Apollo astronauts collected rocks and things like that, and they've looked at lunar meteorites and things like that, then the isotope content from both is very, very similar.
So which would imply that there isn't an impact, but rather the Moon is just formed completely of matter made from Earth.
There's a few ways around it. There's a few ways around this.
I guess Theia would have been created roughly in the same way that Earth was.
No, this is the point. The likelihoods. So, yeah, this is astronomers have thought about that, and the likelihoods of another planetary body not formed in the area of the Earth, it being of similar composition, is wildly unlikely, because Venus is nothing like the Earth in terms of its composition. Neither's Mars. The isotopes are all completely different. So it's incredibly unlikely that you would see something similar.
So surely that's a slam dunk for the hypothesis then.
That, as in, it's game over for it.
Yeah, if it's unlikely that a planet can form with a similar composition.
So, but here's there are a few ways that it could happen. So imagine Theia blasts into the Earth, right, and smashes into the Earth. Big chunk of it comes off. Also, a big chunk of the Earth comes off, and then it's now molten at a certain orbit. Now, maybe Earth had been hit by previous other impacts, or maybe it had little tiny moons around it anyway. Now, what happens with this great big molten ball is that it slowly drifts out, and all those moons, it basically mops up all those old moons. And of course, what happens there is the old moons that are made up of the same thing as Earth get deposited all over the surface of the moon, so that you have this moon covered in old bits of Earth. And so that's why we would. So you'd have to dig down a lot deeper.
So if you dag, yeah,
we're back to William Shakespeare, past tense William Shakespeare.
If you dug really far down in the moon and found that the composition there was vastly different to Earth's, would this be evidence then for the hypothesis?
Yeah, I think that would help out.
Because that is one way out, where you can just say the mechanics in the impacts would be such that just based on probability, the stuff that makes up Earth makes it to the outside, and the stuff that made the impactor is on the inside.
Yeah, and so you kind of get rid of that.
Like if you chucked, I don't know, a bit of feta covered in egg yolk at some breadcrumbs, you're likely to get a thing which is feta covered in breadcrumbs, right?
Yeah.
You're not going to get breadcrumbs covered in feta or an even mix of them.
Yeah, no, true. So yes, I guess. Yeah, I mean, I get your point. So yes, that's one way out of it. And there's variations on the giant impact hypothesis. So you could have...
Yeah, it's like an umbrella term.
Yeah. Well, it's not. As in I think the giant impact hypothesis now really is like very specific computer simulations of Theia coming in and creating this,
So why isn't it called like a theory then?
It's nowhere near up to theory level evidence for it.
Do you think
There's a lot of evidence for it. I mean, we haven't even discussed, like, one of the sort of really exciting bits of evidence for it is the fact that the Earth has been slightly knocked off its axis. So it's obviously had a major impact, and its axis gives us our weather. I mean, the moon, and the fact that we've been tipped off our axis, and the fact that the moon's there now holding us stably in that off-axis orbit is unbelievably important for the stability of Earth's weather systems to be able to support life, and for life to actually
seasons and things,
seasons and everything.
To occur. Seasons are a good selection process.
Yeah, seasons are a great selection process, as are tides,
and like things like the amount of radiation and like seasons.
Yeah,
are sort of in the sweet spot between killing off too many animals,
but also driving,
but being a bit harsh enough to drive evolution.
Yeah. So it's the moon and that impact are incredibly important for life on Earth. Probably.
Isn't it a major coincidence that we find ourselves on the planet that has
has life? I think that's some form of tautological mistake.
Some sort of anthropic bias.
But yeah, sort of. I mean, of course, there are. So you could have had a merger of planets as well. So it could be that maybe two planets merged together and smashed together, and then formed the Earth-Moon system. It could be that there was multiple impacts. That over time there's lots and lots and lots of different impacts. There's your donut hypothesis.
I think it's true just because it's funny.
Yeah, it would be. I mean, it would be so good, wouldn't it, to visit a star system where one of the planets was still in a donut shape.
Yeah, it's just like the odd one out.
Yeah, but
All
my
of them
God,
are spheres, and then it's just like a donut.
Of course, I mean, obviously over time, the sort of big other hypothesis, I mean, is the capture one, for example. Maybe the moon wasn't formed anywhere near us and it was captured by Earth's orbit. But that seems highly unlikely because the moon is so big that if the Earth was to try and capture it, its atmosphere would have to be unfeasibly large and dense for the moon to sort of be dragged into Earth's orbit.
That's not the only. It could just pass close. Like, it's not necessarily caused by the atmospheric breaking.
No,
I don't think that's necessarily the main.
But it would be the only way to capture something as big as the moon.
No, because you're litho breaking. Like, it's like literally hitting it. That's
I mean,
how it's slowing it down.
okay, yeah. So the moon could have come in and whacked into the surface of the Earth, but it would probably have just been fully absorbed if that was the case.
No, but it's the sweet spot between not being fully absorbed and sort of.
But not only, it just doesn't look feasible, and the fact that the moon is very similar composition to the Earth, again, kind of puts the nail in the coffin of the capture hypothesis.
Yeah, but
I would imagine there's still people that believe that.
Helicopters don't look feasible, Dad, but that doesn't mean that they're not possible.
One exciting one is that the moon could have been caused by a giant nuclear explosion. So that's the centrifugal force of an earlier spinning proto-Earth would have concentrated all the heavy elements such as thorium and uranium and all that, and gone critical and caused a natural nuclear explosion.
So basically the hypothesis is the Earth was a nuclear bomb.
A massive nuclear bomb, yeah. That's quite a cool theory. Another one is that Earth nicked the moon off Venus.
Which explains why Venus doesn't have a moon.
Yeah, but one of the other explanations for Venus not having a moon is because Mercury and Venus are interfered with by the sun's
the further you go out, the more likely you are to have moons.
Because the sun's not being a naughty Norman
because the sphere of influence is much bigger because the sun is further away. The Lagrange points will then, are further out.
Yeah. Often we think of the moon as being freakishly large compared to, its planet, which it seems to be. But maybe we don't really know because you've got Venus and Mercury that you can't count because they're too close to the sun and are being interfered with the sun. And then you can't really compare it to Saturn and Jupiter because they're completely different and they're huge and gaseous. But if you take all of Jupiter's moons and add them together, the ratio of mass isn't too dissimilar between the Earth and its moon and the rocky core of Jupiter and its moon.
But Earth's moon still, unless you don't include, as long as you don't include Pluto, the ratio of Earth to moon is the smallest ratio from planet to moon of any planet in the solar
Pluto
system.
and Charon obviously is
ridiculous. They're basically like a binary.
But both of them are smaller than the moon.
Yeah, like that, which is why it got demoted because it's just you can't call that a planet if it's smaller than the moon.
Yeah, I mean the moon is bigger than all the dwarf planets in the solar system as well by quite a long way.
Yeah, well, like not by a long way, but it's
quite a long way. It's considerably bigger than Pluto, and it's considerably bigger than Ceres and Make and all those kind of weird ones.
What's the other? The Quoo.
I don't know. I just don't know.
I don't know all the dwarf planets by heart.
But yeah, I mean, it's what's amazing is that we're still finding out loads about the subject of the moon and the way that all the different kind of how old the rocks are, how old the moon must be, the isotope information that sort of tells you how similar it is to Earth and how dissimilar it is to Earth. And of course, one of the really exciting things we should talk about, water on the moon is I guess one of the sort of big news stories, isn't it, of the last few years.
So when was the water first found on the moon then?
It's been hypothesized for a few decades.
The
Right?
The French named the dark patches on the moon as lakes or seas.
Well, yeah. So I mean, yeah, the mares and yeah.
So it was thought to have
at
seas.
some point it was thought to have seas, yeah, but of course they're just dried up lava beds.
Yeah, sort of like seas in a way.
Yeah. Well, except you wouldn't want to go swimming in them when they were molten, flowing around the surface. But yeah, obviously, to have water on the surface of the moon is completely. There's no way you can have water on the surface of the moon that's being exposed to sunlight, because the solar radiation will do this thing called photodissociation. In other words, water is like being shot at by a billion bullets from the solar radiation.
Yeah, it just boils water. There's no atmosphere to stop it.
It smashes the atoms apart. It smashes the molecules to bits. So you can't have water on the surface. However, in the 60s, scientists did realize that you could have comets that may be landing on the moon, and the fragments of those would end up in craters that were permanently in shadow. But not only that, the solar wind itself could actually interact with these very oxygen-rich lunar rocks as well and create water on the surface. That as long as it was hitting shadowed craters, you'd end up with a little bit of water there.
Yeah, because the thing about the moon, there's no atmosphere, or there's barely an atmosphere. There's like
how is it?
10 tons
of atmosphere.
The entire atmosphere.
Yeah, covering the whole of the moon, which is like a bit ludicrous.
Yeah, but because it doesn't have an atmosphere, there's no refraction or diffusion of light that can get to shadows. So, for example, like for the Earth, you have the sunlight as the main light, but most of a lot of the lighting in shadows and occluded parts are still lit by the blue sky.
Yeah, well, the atmosphere.
In the UK,
glowing atmosphere.
It's just mostly diffusion, right? It's just grey. Like shadows don't exist here, but
yeah. So, but on somewhere like the moon, where there's no atmosphere diffusing the light, it's every shadow is very sharp. And so, yes, there's loads of permanent shadow. Guess how many square kilometers or square miles, I'll let you have that, of water that there is. Well, how many square miles of permanent shadow are there on the moon?
10
square miles? No, 5,400 square miles of shadowed area.
Are these appropriate places to put a base?
Absolutely. So what you want to do is build your Mars habitat on Mars, and your lunar habitat you want to build on the moon, and you want to build it near these places where you may get water. I mean,
but not just near them. I mean, like, would you want to just put your habitats there so you don't have to worry about radiation and stuff?
Yeah, but if you're in shadow, I suppose you might have problems communicating with the Earth.
You just put your dish like on a wire,
just on the edge. Of the crater. Yeah, I mean, maybe that would be a good thing, but it would be pitch black as well down there. Remember, but there's been lots of satellites that have space probes, lunar satellites, I suppose, that have gone to check out this water. So Clementine was one, and in 1994. Basically confirmed that there were signatures of water on the lunar surface. Although Arecibo, R.I.P. Arecibo, of course, suggested that it over kind of stated those. But there's been 1998 lunar prospector that was finding water. Chandrayaan, the great Indian orbiter from 2008, Chandrayaan-1. Confirm the existence of water ice on the surface. So it's a lot of these spacecraft in recent years have been confirming that there's water on the surface. So in 2020, molecular water was found on the sunlit surface of the moon by things like SOFIA, that telescope that's mounted on a 747.
Have they found black superionic ice.
I haven't found black superionic
The
ice.
11th state of matter.
The 11th or 12th state of matter, yes. How'd you get it again?
So you put ice under really high pressure and then fire it with super lasers.
Super lasers, yeah. And then you get a new state of matter. Very useful.
The only place in the universe where it exists is in a lab.
It's in a lab. I don't even know whether it's been made or whether it's just hypothetical.
I think you have to make it in order to confirm it's a real state of matter.
Mm.
The recipe just seems oddly specific for it not to have been done.
Mm. Do you know what the name of the sort of bulgy shape of the moon is?
I don't know. What is it?
A scalene ellipsoid.
Could have guessed that.
Could you?
Yeah.
Another really interesting thing is that we know that the moon is drifting away from the Earth because of reflectors put on the surface by Apollo astronauts.
But we could. It has been known before then. By
Well, there's lots of.
You can calculate it using Newtonian mechanics.
Yeah, well, there's lots of there's lots of interlocking jigsaw puzzle pieces of scientific knowledge that keep confirming it, that also help to confirm other bits of scientific knowledge.
Yeah, it's definitely true that it's going away, because not only do you have the reflectors on the moon, but you can also calculate it without them.
One of my favourite bits of evidence is a very recent piece of evidence where there's these shell-like animals that have been around for millions and millions and millions of years, and they put on a layer of shell every day, and that layer of shell will tell you, just like tree rings, how long the day was. so it'll tell you literally day by day what the weather was like when that animal was alive.
I guess the problem with this is you can only know you can only know the length of the days on Earth during the time this animal was alive.
No, it's alive now.
No, I mean there's this moon Earth impacts happened.
Oh yeah, no, it was way before then. Yes, but what it shows is that, maybe a billion years ago, when this thing was around still, this shell-like animal, the days were lots shorter. And the days were a lot shorter because the Earth is spinning faster, and then the moon is then stealing some of that spin to drift its orbit out further and further.
It's got like a kind of perpetual gravity assist going on.
Yeah, essentially, yeah. And so it's being pushed into a larger and larger orbit by the fact that it's stealing momentum. It's stealing the angular momentum.
Yeah, because every time a satellite goes by Earth to get a gravity assist, it's slightly lengthening the day a bit.
Yeah, and if you reverse, so if you measure how far it's drifting from the Apollo reflectors, like a centimetre a year or whatever it is, and then reverse that, the data from that exactly matches the fossil record of these shell-like animals, and it's a perfect example.
Yeah, so that's like the third data point for how much it's going away,
and that's great for scientists where you've got like a really, really solid piece of knowledge, and that every time it's tested, it by anything.
Yeah, that's true for a lot of things where you just have like three independent things which all agree with each other.
Really agree very strongly with each other, and every time. But what's even more exciting for scientists is when a fourth piece of information comes along, and it's like, this doesn't fit the data at all, and now you've got to find out why. You've got to find out why that is, and I guess that's the same with this. The great impact hypothesis. There's lots of reasons to think that it's right, but there's also some annoying anomalies in there that make you think, maybe it's not right. And that's mainly down to the fact that the composition of Earth and Moon are too similar. It's like, oh damn, they're just a little bit too similar. You'd expect.
Yeah, but feta cheese, Dad.
It's the feta cheese with breadcrumbs. Yeah, I like it. Did you think you were thinking of feta cheese because of the name of Theta, the Mars-like planet that crashed into?
No, that's just like the first thing that came to mind when I was thinking of bread, like breading things. I think it's a Greek delicacy, feta cheese and breadcrumbs.
It's Thea, isn't it? Not Theta.
Yeah, it's Thea. Theta is a Greek symbol,
yeah, Thea.
usually denoting angles.
The moon, in essence, George, it isn't made of cheese.
But it is made of talcum powder.
And it's solid. It's not a hollow object where Nazis are hiding inside.
But there is an ancient alien civilization that used the moon as a spacecraft, and they made the pyramids. That's just a fact.
Oh, is it?
Yeah.
Oh, no, I'm a little bit confused about all the stuff we've been talking about. So, do you know what the first artificial object to reach the moon was?
Was it Russian?
It was
thing?
Russian. It was Russian. Yeah.
Was it the Sputnik 8?
No. It's actually quite a boring name. Luna 2.
They should have called it Moonly 2.
So that was in 1959. So very early. So
What was the first successful hard landing? Or litho break, as I like to call
that
it.
was Luna 2.
It can't be both.
No, it was the first. No, I'm saying no. I haven't told you when Luna 9 was. Luna 9 was the first soft landing.
Oh, right,
and that
sorry.
was 1966. So it took them 7 years to sort of get it right.
Mm-hmm.
But that's pretty cool, though. In 1959, that is really early, isn't it?
That is pretty early as far as technology goes. I mean, they haven't even invented a proper computer then.
No. And how many men have been on the moon?
20.
20.
No, 14.
Oh, close.
12.
12, yeah. 12 moon have been on the men. Yes. Yeah. And yes, and they were the people that brought back the rocks that have helped people understand.
But perhaps thousands of tardigrades have been to the moon.
Perhaps on that Israeli mission.
Billions of viruses and bacteria.
Yeah, almost definitely billions of viruses.
Perhaps even trillions.
Maybe even scabillions.
Or,
I heard some ridiculous fact about viruses.
Really?
If you got all the viruses on Earth and put them end to end, how far do you think they'd stretch?
7 light years?
It is something ridiculous like that.
Yeah, I have heard this fact as well. Like, it goes past Alpha Centauri.
Yeah, way past. It's ridiculous. It's so far.
Also, human DNA is 7% ancient virus that have accumulated over billions of years.
Yeah. I'm going to say bye-bye to the Spodcats because that's a long and hard episode to edit. So, bye-bye, Spodcats.
Goodbye.